Continuing with section 1.3 on complex numbers, now we're ready to divide complex numbers. So we want to divide the following and write the quotient in standard form. Remember what that means, a plus bi. Our answer needs to look like that. Okay, so we talked about the technique we were going to use. We were going to multiply by the conjugate. Well, we have these two complex numbers here. We multiply by the conjugate of the denominator in the top and the bottom, right? You can't just manipulate the bottom. You have to multiply the top and the bottom. So in other words, I'm going to take 6 minus I over 4 plus 3I and multiply the top and the bottom by the conjugate of 4 plus 3I. So what would, and this will be equal to 1 because it'll be the same on the top and the bottom. What is the conjugate of 4 plus 3I? Yes, 4 minus 3I. 4 minus 3I. Now, what did we say when you multiply? Let's just remind ourselves. When you multiply a plus bi times a minus bi, the final answer was always a squared plus b squared, right? So we can use that. We don't have to foil the denominator every time, but we do have to foil the numerator. So in the top, 6 times 4 is 24. Negative 3i times 6 is negative 18i. Negative I times 4 is negative 4i. Negative I times negative 3i will be positive 3i squared. And in the bottom, it's a squared plus b squared, right? We know it's going to be that. You can FOIL if you want, but that's what it's going to be. Okay, so in the top, we have 24 minus 22i plus 3 times negative 1. There's never an I squared in the final answer. All over 16 plus 9, right? I'm going to run out of room, aren't I? Okay, so this equals, we've got negative 3 and 24, so we've got 21 minus 22i over 25, but that's not in standard form. We have to separate out a and b, so it's 21 over 25 minus 22 over 25i. Okay, the real part is 21 over 25, and the non-real part here is the 22 over 25i. Okay, so the idea is to multiply the top and bottom by the conjugate of the denominator. Top and bottom, because this is the same thing as 1, and so that's perfectly legal to multiply a number by 1. Okay, let's try that here. See if I can start in this place and have more room. Negative 4 plus 5i over 1 minus 6i, multiply the top and bottom by the conjugate of the denominator, which is 1 plus 6i. 1 plus 6i. Good. Okay, so what do we get? Negative 4 times 1 is negative 4. 6 times negative 4, negative 24. Or 6i times negative 4, negative 24i. 5i times 1 plus 5i. And 5i times 6i plus 30. I'm running off the page, 30i squared, right? That's the numerator. The denominator is a squared plus b squared. Or FOIL it if you like. Okay, so we have negative 4. We've got negative 24 plus 5, negative 19i plus 30 times negative 1. I squared is always negative 1, and here we've got 1 plus 36. All right, so that's negative 30, and that's negative 4, so I have negative 34 minus 19i over 37. But that's not in our standard form, so we need to break it out. Negative 34 over 37 minus 19 over 37i. A plus bi. Okay, so that's the little trick for dividing complex numbers. Multiply the top and the bottom by the conjugate of the denominator. Quadratic equations with a negative discriminant, negative b squared minus 4ac, have no real number solutions. However, when we extend our number system to allow complex numbers, now we always have a solution. Having a negative b squared minus 4ac doesn't end in no solution. If n is a positive real number, we define the principal square root of negative n denoted by the square root of negative n now is going to be I times the square root of n. We'll factor out the negative 1, take the square root of negative 1 and get I. Okay, so here let's solve this simple quadratic equation in the complex number system. X squared plus 8 equals 0. Okay, so use the square root method. We could do that. Minus 8 minus 8, x squared equals negative 8. Previously we said there is no real solution to that. That's true. There is no real solution to that, but there is a complex solution to that that includes imaginary numbers. Take the square root of x squared plus or minus the square root of negative 8. So x equals plus or minus the square root of 8, or let's break that down. What are our factors of 8? Our perfect square factor is 4 times 2 times I. There's our 8. Oh, not I. I'm getting in a hurry, aren't I? 4 times 2 times what? Negative 1. There we go. So x equals plus or minus, take the square root of 4, I get 2. This will stay in the radical. Square root of negative 1, I get I. So those are my two solutions. I've got 2i square root of 2 and negative 2i square root of 2. Simplify the radical always. So finally, let's conclude here. Back to our analysis of b squared minus 4ac. If b squared minus 4ac is positive, greater than 0, two unequal real solutions. B squared minus 4ac equals 0, one repeated real solution. Or if b squared minus 4ac is less than 0, in the complex number system, we say the equation has two complex solutions that are not real, and these are conjugates. Maybe we have noticed here, but these would be conjugates. These are both pure imaginary numbers. There's no real part, but they will be conjugates of each other. So now we have a new conclusion in the complex number system when we have a negative discriminant.